Okay, our next lesson is going to cover the concepts on exponents, factoring, and quadratics walkthrough, but day 2. So make sure you are on the right part of the notes. This is day 2. And the first concept we're going to look at are factoring some quadratics. So the first thing I look at is 8x squared minus 12x. And the question says, do these have any terms that are in common? And it does. For instance, the 8 and the 12 can both be divided by 4. And then x squared and x mean that they both have an x in common. So the question we have is, if I pull out or factor out a 4x, what would be left? And the way it's worded here is, what do I have to multiply by 4x to get back to this original problem, 8x squared minus 12x? Well, this is the opposite of distribution. So when distribution says to multiply, factoring out is really kind of like division. So think of it as dividing both of these by a 4x. We're not actually dividing, but it's like dividing by a 4x. So when I do that, I am left with, let's see, 2x and then minus 3. And if you're not sure if you did that right, you can go ahead and redistribute the 4x, and sure enough, you will get the right answer. So moving on, x squared minus 5x minus 36. Do any of these terms, are there any terms in common? And unfortunately, the answer is no. Now, we need to factor this. This is called a trinomial. And the way we factor trinomials are, we think about first, outer, inner, and last. So the backwards of foiling. So the first two numbers, when I factor, I go in the first positions, which are here and here, are going to have to multiply to give me an x squared. Well, that's an easy one. That's going to be x times x. Now, the next part that I look at is I always look at the last term. The last terms have to multiply to give me a negative 36. So something times something has to give me a negative 36. There's a lot of options. There's 12 and negative 3, you could flip that around and say negative 12 and positive 3. There's 9 and 4, one of them being negative. There's 18 and 2, there's 36 and 1. Well, if I kind of look ahead in the problem, when I go ahead and multiply my outer plus the multiplication of my inners, it's got to come out to a negative 5 in the middle. So I'm thinking 5 and 4 would be a good 9 and 4 would be a good option, except I got to figure out who's going to be negative. So if I put a negative 9 and a positive 4, and I try to check my outer plus inner would give me a 4x and a negative 9x, which sure enough does give me a negative 5. So this is the correct factorization. Now, depending on who is your Algebra 2 teacher, you might know some other methods. What we did was basically a diamond. Some teachers teach slide and divide, not needed for this one necessarily. But the idea is, if you can factor this quickly and easily, it'll give you a lot less grief on the ACT, because they do ask you to factor a little bit. X squared minus 64, there is nothing in common, unfortunately. But what is great is that I do notice they are both perfect squares. And when you factor the difference of perfect squares, it's a little pattern. What you do is you take the square root of both of the numbers. So for this pattern, it would be a and b. And then one's a plus and one's a minus. So for x squared and 64, if I square root both of those, I get x and x. And then the square root of 64 is 8. So one's going to be a plus an 8, and one's going to be minus an 8. Those are my favorite problems. They're very easy. Okay, example number 4. I think we have another difference of two squares. There's nothing in common, so we're just going to think about taking the square root of both of them. So we get 3x and 7. And then the rule says one's positive and one's negative. Now in example 5, not only do they want you to factor, this time they actually want you to go ahead and solve, because it says equals 0. So we have two ways to do this. You can factor out what's in common and try to factor it like normal, or you can just solve it using square roots. The reason we can use the square root is because there's only one x in the problem, there's not multiple x's, so we can just isolate it. So I'm going to go ahead and add the 50 over. Not the only way to do this problem, but it sure does work nice. And then I'm going to go ahead and divide by 8. We're going to get x squared equals, let's see, 25 fourths, because both of those can be divided by 2. Now when I square root both sides, and I square root a fraction, I end up taking the square root of the top and the bottom. And remember, when you square root in an equation, it's plus and minus. So the square root of 25 is 5, square root of 4 is 2. The answer is plus and minus 5 halves. The answers, I should say. There were 2 answers to that problem. Okay, example 6. We're going to have to factor this, and then we're going to have to solve and set them equal to 0. Since this is a trinomial, we're going to use kind of our diamond factoring method. What times what will give you x squared? Well, that would be x and x. And then we're looking for 2 numbers that multiply to give you a negative 28, but then when you add them together, it gives you a positive 12. So I'm thinking a positive 14 and a negative 2 would work great. Now here's the key. Because it says equals 0, you got to set both of these terms equal to 0 and give me your 2 answers. So we get x equals negative 14 and x equals positive 2. Careful on number 7. At first it looks really, really hard, but I'm thinking all of those are divisible by 3. So let's go ahead and divide everything by 3, and since it's an equation, I can go ahead and do that. So we have x squared minus 7x plus 10 equals 0. And now we have a very easy trinomial that we can use a diamond on. So what multiplies to give me a 10 but adds up to a negative 7? I'm thinking negative 5 and negative 2. So when I go ahead and set these equal to 0, I get x equals positive 5, the opposite, and x equals positive 2. And that is the wrap up on day 2. We will talk about day 3 on the next presentation.